I'm going to keep going with the questions now. This is a really difficult complex number question. I remember doing it. The kind of, it's a bit, this leaving cert was really bad. It was like it was kind of impossible to get full marks on any question, but I'll do this one now just to show you. I don't know if you've decided to give up on complex numbers or if you're keeping them just in case, because in fairness they can be a nice way to pick up a few marks, especially if you just have a really difficult question on the day. Like we had this kind of one earlier, wasn't a great question. So just in case a question like this comes up on the day, I guess it's good to just be able to do some of the parts of complex numbers. So we're told 1 plus I is a root of this equation here, and then we're told to find the value of p. Okay, perfect. So all we're going to do is sub in z is equal to 1 plus I, or 1 plus I, wherever z is, and then we know it should be 0, and it should work out nicely enough. So we're going to have 1 plus I squared plus 3 minus 2I multiplied by 1 plus I plus p equals 0. Now let's multiply this out. So we get 1 plus I times 1 plus I plus 3 by 1 plus I minus 2I by 1 plus I plus p equals 0. And then 1 by 1 plus I by 1 plus I plus 3 plus 3I minus 2I squared, 2I by I, plus p equals 0. Right, and there we finish this one. 1 times 1 is 1, 1 times I is I, 1 times I is I, and I times I is I squared. Plus 3 plus 3I minus 2I squared plus p equals 0. Now what we do is, remember, we use information, I squared is minus 1, so this is going to give me 1, leave the 1. I'm going to add these two i's, so 2I, then I'm going to get a minus 1 for the I squared. Then over here, leave the 3, so plus 3. I'll add these two, so 3I minus 2I is just plus I. Then here, minus 2 multiplied by minus 1 plus p equals 0. Now, this one cancels with that one. 2I plus I is 3I. And then we're going to get the plus 3. Minus 2 by minus 1 is plus 2. Plus p is 0. Now we get 3I, 3 plus 2 is 5, plus p is 0, and now what we do is we move the 3I over and we move the 5 over. So we get p is equal, take it away from both sides, minus 5 minus 3I, and that's our answer. That's the value of p, and yeah, it looks okay. Then we're told, this is part B, it has nothing to do with the last part, we're told to use de Moivre's theorem to find the values of w for which w squared is equal to this, and then give each value in this form. So if we're using de Moivre's form, or de Moivre's theorem, the first thing that we should always think is polar form. So you know this by now as well, and that means we need to find r and we need to find theta. So you always plot it on the diagram, so I'm going to draw my diagram here. So remember, this is the real axis and this is the imaginary axis. Now look at the real part, it's negative. So that means we're going to be over here. But the imaginary part is positive, so we're going to be up here. So our complex number is going to look something like this. And then, so then this is going to be root 3 here, and this is going to be 1 here. So can use Pythagoras's, like we said before, to find or. So we know that or squared is equal to the square root of 3 squared plus 1 squared. So if you put this into your calculator, you'll see that r squared is 4, which means r is 2. Then for the angle, I can say that tan of alpha, I'm not going to do theta yet, because if you remember, I'll draw my little triangle here. So This is my angle alpha, then this is length 1, this is length root 3. This is, I've actually just found this, but I've just found this side here, but we won't worry about that. So we can say that tan of alpha is equal, remember tan is equal to the opposite over the adjacent, so root 3 over 1. Okay, and root 3 divided by 1 is just root 3. So we can just leave it like this. Then we can say that alpha is the tan inverse of the square root of 3. And I actually don't have my calculator on me still, but remember I'm going to do it in degrees. I think it's 60 degrees, and I can check quickly. Tan of 60 degrees, yeah, tan of root 3, 60 degrees, perfect. Okay, at least I remembered that. So alpha is 60 degrees. Now, remember I always said that what angle we found? We have found this angle here. This is alpha. But the thing is, we're looking for this angle here. So obviously this is like here to here is 180 degrees. And then if this little bit here is 60 degrees, this bit here must be 120 because it's 180 minus 60. That's how we get that. So then I can say that theta is equal to 120 degrees. So now what I'm going to do is I can say w squared is equal to whatever we were given at the start, minus 1 plus root 3I. And now I can do another equal sign, and I can say in polar form, this is going to be the same as or. And then do brackets, cosine 120 degrees plus I sine 120 degrees. Okay, so that's how you do the polar form. Now we're looking for the values of w, for which the w squared is this. Now we can use the Moivre's theorem because it's in polar form. So I have the tables book here just to show you. It's on page 20, I think. Yeah, the Moivre's theorem is right here. So don't need to worry about the second part of it. It's just this bit here. When we have this whole thing to the power of n, what we do is we raise or to the power of n and we multiply the angle by n. So the way we do that here is we're looking for w, but we have w squared. When we know the square of something, but we want to get back, what we do is we square root it. Or, I remember I said last week, we raise it to the power of a half. So that means w is equal to 2. Because we're square rooting, okay, I'll do it the proper way. But so 2, I'm going to put a big bracket here, cosine 120 plus I sine 120. So there's actually 2 ways of doing this. I might do it kind of not, and then what we do is raise the power of a half. But I'm thinking I might do it the cheeky way, kind of not the best way. It actually is the best way of doing it in this case. It's not the most proper way, but remember I said earlier if we square root something, it's plus or minus. So technically I'm going to plus or minus, but honestly you shouldn't do it this way. But right now, when we get to this step, this is when we use de Moivre. So now we're going to use de Moivre's theorem. So what we can say is then w is equal to plus or minus. Now it's 2 to the power of a half. That's how de Moivre's theorem works. And then we multiply the power by a half. So 2 multiplying it by a half by 120 is 60. Same thing with the I sine 60. Okay. Now I just want to see what form they want us to give it in. So they want it in the form a plus bi. Okay, 2 to the half is the same as the square root of 2. And then cosine of 60. Again, I don't have, use your calculator for this, but I don't have mine on me. So I'm going to have to use the tables book. Cosine of 60 is a half. So that's a half. And then plus sine of 60 then. Sine of 60 is root 3 over 2. Right? Yeah, root 3 over 2. Okay. Plus I root 3 over 2. Okay, so then we can say that I'll do w1, and I'm going to do that with the plus. So do 1 with the plus and then do 1 with the minus. So I'm going to do that with the plus though. I just want to check this is right. Looks okay. Cosine is a half. Yep. Okay, I think it's okay. So for my first solution, I'm going to get root 2 times a half. So root 2 divided by 2. Plus, jeez, that's kind of strange, root plus, oh sorry, so root 2 by root 3, I can write that as root 6, so I root 6, that cannot be right, I'm going to have to check the marking scheme because this looks stupid. Okay, and then W2 is equal to, do it with a minus now, sorry, so minus root 2 over 2, minus I root 6 over 2. I might be a better way of writing the I root 6 part, I'm not sure. I think it looks okay though. I'll just check the work, so by a half, yep, I think it's okay. Alright, I'm not going to bother checking the marking scheme, I think that's okay. Fuck, I might as well. Anyway, I'll have a look after I do it. If it's wrong, I'll correct it, but this is the part now of the question that they kind of went a little bit off course, and the thing I'd say I always said about this paper is that they really went into like the crevices of the course. So this stuff is on the course, but it's such a small part and people don't actually study it that it was kind of really bad out that they did this. But yeah, I'm just going to show you how you would go about doing this. So this is a complex number here. This is u. Then we're told write the complex numbers iu. Oh, sorry, okay, we have to do it in the terms they want. I didn't realize that. Okay. We are asked to plot them. Alright, so first part isn't too bad. It's just a bit of maths. We should be able to do that, no bother. 2023. So I'm just pulling up the marking scheme now. Just checking them right. Let's have a look. Oh yeah, it is right, yeah. Okay. Sorry, I did not think it looked right at all. It looks so stupid, but amazingly enough, it's perfect as it is. Nice. Okay. So for the first part, IU, yeah, this is U. U is A plus BI. So to get IU, we just multiply by I. So I times A plus BI. Don't let this confuse you. Okay. So I times A is AI, and I times BI is plus BI squared. Okay. Now remember, I squared is minus 1, so we can rewrite this as AI plus B by minus 1. Which is minus b, because now b becomes real, so we move that to the front, plus ai, okay? So that's 1, are we asked to, okay, yeah, and then iu conjugate. So for iu conjugate, that just means we change the sign of the imaginary part, so minus b minus ai instead of plus ai. That's what this bar means, it means the conjugate. All you do is change the sign of the imaginary pair. Then we're told to plot and label the complex numbers iu and iu conjugate on the diagram above as accurately as possible. So this is not easy to do, but basically when we multiply by I, like we did here, what actually happens is it rotates it to the left by 90 degrees. So what it's going to end up looking like is this, or something close enough to this. This would be iu. Okay, then for iu conjugate, it's the exact same thing, except it's just going to be flipped about the x-axis. So it's going to look something like this. Okay, now that is the hard part, really. I'm guessing 5 marks for this. So basically, this should form a 90-degree angle. It doesn't exactly, I've not done it perfectly. And then what we do is just flip this one upside down. Now this is the one that's probably the hardest part. Actually, state a transformation or a series of transformations that would send u to iu conjugate. Do not include a translation in your answer. So what they want us to do is they want us to describe a transformation, or we're going to do a series because I don't think there's one that can do this. So we want to say, how can we see this? We have this complex number, and we want to say, how can we send that to this complex number here? So the way we do this is we will say, first of all, see the way here I said multiplying by I. So we're going to do the first one. We're going to say, how do we get here? And then how do we get to here? So this is the first one here, and then this is the second one here. So for the first one, we rotate 90 degrees anti-clockwise, so against the clock, okay? So we are going to rotate, it's U, isn't it? Rotate U 90 degrees anti-clockwise. And I'm going to say about the origin, because just about means kind of what you flip it about. Doesn't really mean anything, but I'm just doing that just to say how to do it properly. We're going to rotate U 90 degrees anti-clockwise about the origin. So what that does is it flips it to IU, okay? Then to get from IU to IU conjugate, so we are going to perform, I think it's called central symmetry, or no, axial symmetry. Then we'll say perform axial symmetry about the x-axis. So what that means is mirror. Axial symmetry is a fancy word for mirror. So all we're going to do is take the mirror image of this here, and that'll give us IU. Okay, and that's how you do that question. Honestly, that's a really tricky question. So just I wouldn't worry at all, especially with the transformation part. I wouldn't worry about this at all. This part is just a bit of algebra, to be fair. The plotting and labeling was a little bit harder. I'd focus a bit more kind of on the de Moivre's theorem. Just, it's probably worth the most marks. I think even this year was worth a lot, so